Right. Hello and welcome everyone to this edition of the Social Science Data Lab at the Mannheim Center for European Research. My name is Ruben Bach, and I'm very happy to welcome you to today's workshop on From Evidence Gap Maps to Systematic Reviews and Meta-Analyses, Approaches, Techniques and Tools by Jessica Daikeler, to my right here. The Social Science Data Lab is an event series at the Mannheim Center for European Social Research that provides a platform for early career researchers to present tools, methods for the collection, management, analysis, and visualization of data in the social sciences. Our speaker today is Jessica Daikeler. She's a senior researcher in survey methodology at GESIS, just across the street here, Leibniz Institute for the Social Sciences. She's coordinator of the KODAQS project at GESIS, and in her research, she specializes in survey mode effects, and she works at the intersection of digital trace data, or as you call it,
digital behavior data,
digital behavioral data, and survey data, including also data donation research. In her talk today, she will present a basic introduction to various approaches, techniques, and tools of quantitative research synthesis, and we will be provided with evaluation criteria, how to review an evidence synthesis, and we will see some exemplary applications. Thank you very much, and I'll hand over to you.
Thanks for having me, and thank you, Ruben, for this warm and welcoming introduction here part. Yes. So Ruben already introduced me. Jessica Daikeler is my name. I received my PhD here from the University of Mannheim. Now I'm going to work with GESIS for quite a long time here. I'm leading a team which is their survey design and methodology department, the team assessing survey data quality. And Ruben already told you something about my research, and actually in my PhD, I really did my PhD on assessing synthesis-based, evidence-based methods in survey methodology. This is where I received my PhD from here, also from the University of Mannheim. So yes, but before I'm going to start, I would like to point you to some advertisement of KODAQS, which is a project I am leading with GESIS. So you see here our famous house graph from the KODAQS, and KODAQS has lots of cool offers for you guys, so for social scientists. We, for instance, develop an academy which is called KODAQS Data Quality Academy. So KODAQS circles completely around assessing and correcting for data quality issues in the social sciences. And here for the Data Quality Academy part, this has several layers, but the layers the one layer we're gonna start in November is now a 6-month certificate program where you can become a data quality steward for the social sciences. And we have a nice schedule for you prepared to, if you want to focus on survey data, digital behavior data, or linked data, and then you're getting some new cool ideas, tools, what is data quality and how to correct for data quality. A second cool thing we are going to develop is this one here, is the data quality toolbox. You can think of the toolbox like a one-stop shop, which is a website in the internet, and when you want to assess survey data quality or DBD data quality, you will find representation or measurement perspectives, and then you can click on these perspectives and you will find helpful tools which guide you through the R code, how to assess and evaluate and also correct for data quality in your social science. So, okay, but so much on this. You can check also the QR code here or check the website. Then let's go to start. For today, back to meta-analysis. We have two goals for this talk. First, I would like you to familiarize with evidence-based methods. So what are evidence-based methods in general? And I would like you to learn some fundamental steps and want to guide you through all the process of an evidence-based method. Yes. Then we are going to start with some methodological introduction about key concepts. What is the difference between an evidence gap map, a systematic review, and also a meta-analysis? Then I would like to take you with me on a journey on 3 different case studies. One is on an evidence gap map. One is, you can see in the second one is systematic review. And the last one is then on a meta-analysis. And then in the end, which is quite cool, we are now living in a world where you have really, really cool AI methods and text mining methods, which help us to get a systematic review ongoing. And I would like you to introduce you to these cool methods in the second bigger part here. And then we're going to talk about evaluation strategies when you have, as a reviewer, a meta-analysis on your desk. And some last thought will be there in the end. Okay. So much on this. Let's start with these 2 quotes. One is from Isaac Newton. I have seen further it is by standing on the shoulders of giants. And the second one is from Karl Popper, which is non-reproducible single occurrences are of no significance of science. So as you may know, the scientific progress builds upon the generation of knowledge, upon the generation of discoveries of past of generations. So we built on those significant findings, and those findings which have been achieved by researchers in the generations before us. So the breakthroughs in science are often collaborative. And in cumulative science, research doesn't occur in isolation. I mean, this is common process. This is how research works. And this is also where meta-analysis come into play. So let's start why cumulative research is important. So there is a challenge of navigating the overwhelming amount of research available today. You see all these journals coming up with new and new publications, so on and so forth. This is often referred to as information avalanche. When addressing a specific research question, like what research findings are there on X, we are faced with a huge volume of studies that must be filtered, understood, and also evaluated. However, it's not just about finding information, it's about evaluating which findings are of high quality, which may not meet rigorous standards. This leads us to important questions. What can we learn from existing research? Are their findings reliable and consistent? And what gaps still exist? Lastly, we were reminded that next door to cumulative research, there's an ongoing replication crisis. So you might remember the replication crisis from psychology, where they found out that there were basic findings in psychology which were established in the 50s or something, and then they could not replicate it anymore, or could not replicate it at all, because they were conducted, these experimental studies, with some student populations somewhere, and this and these findings could then not be put into context for broader populations than to students. And this issue highlights that not all studies can be reliably replicated, which casts doubt on some findings that we might otherwise add to our cumulative knowledge base. It's a crucial reminder to critically assess research before it becomes part of the foundation for future studies. Then this graph here, I like this graph really a lot. This graph depicts the progression from raw information to actionable wisdom. And this is what we are doing in science. So in the beginning, we have lots of information there. And when we are doing some research on this information, we're building here knowledge by connecting different information points and by making sense of them. And then in the final stage, when we are doing our task here, right, is to generate wisdom. The final stage is then here wisdom, where knowledge is applied with good judgment. Wisdom involves taking the knowledge we have gained and using it to make sound decisions, solve complex problems, or predict outcomes. And here, meta-analysis and evidence-based methods could come into play, because you have the information before, then you're doing as primary researcher some research on it, and in the end, you try to summarize everything to bring it to one certain points into one central statement. Yes. This graph is also quite nice. It's called the evidence pyramid. So what is evidence-based? We always hear the term evidence-based movement. What is evidence-based? So evidence-based means to focus on methods in our research with a focus on causal inference, so that the findings we are deriving in our studies are really true in the end. And a tool to classify evidence is the evidence pyramid. The higher we get in this pyramid, the more reliable the evidence of the methods used is. So it is a hierarchy that represents the quality and reliability of research evidence. So you see here this arrow with the quality of evidence as higher as it gets. Yes, so at the base level thingy, we have expert opinions and background information together with case reports and case studies. These are only studies which focus on individual use cases. These are interesting but less reliable for general conclusions and also for science. So it is harder to get these reports or case studies here into a proper publication. In the middle level of the graph, we have cohort and case control studies. So observational studies that explore associations but can't establish causation. Then a level higher, we have randomized control trials, which is kind of the gold standards for experiments, which reduces bias through random group assignments. In these randomized control trials here, the greenish part, you usually have these classical designs. You have a control group and a treatment group, and then you have then a stimulus, and then you could compare both groups. So let's then now getting up a bit higher from the pyramid, where we come to evidence-based methods. So we have systematic reviews here, which summarize all studies on a question aiming to minimize bias. Then at the very top here, then we have systematic reviews together with meta-analysis. And the difference between systematic review and a meta-analysis is in the terminology. In some social sciences, as it is used in some social sciences, is that systematic reviews are more the qualitative part to summarize evidence. So you talk about, okay, this study finds X, the other study finds Y, the reason for this could be Z or something. And in a meta-analysis, you really do it quantitatively. So you summarize and synthesize all the evidence to get to one quantitative final number. What is the difference between response rates in two different modes or something? So what is the takeaway from this here? The higher up the pyramid, the more reliable the evidence. Meta-analysis and systematic reviews are considered the gold standard of scientific evidence because they provide the most comprehensive picture, especially when the evidence-based methods, so when the meta-analysis is of randomized control trials. So you have lots of randomized control trials, a lot of experiments together, and then you derive one final statement from these different experiments. Yes. So are there some questions here so far? Okay, then let's continue. So there are different methods of evidence synthesis out there, and we will target on the next few, what we will target on the next few slides, but how do they differ? So they have one common shared general goal, which is provide an overview. And you can then also think of methods like bibliographies, narrative reviews, or vote counting approaches to generate this central goal, so just to provide an overview. But what is the problem with these methods? Maybe I should go more into detail. What is vote counting and what is narrative reviews? So for instance, narrative reviews is just you type something in a Google Scholar, and then you find some references, and then you write your background part of your paper just from these 5-10 first results from Google Scholar, and then you write a narrative review, and you pretend that this is the latest research status on this field. And vote counting approach is a bit similar. Vote counting is that you just count. There are 10 positive effects, 2 negative effects, 5 null effects. And so, well, I count everything together. So the effect might be a bit more positive because there are more positive findings out there. But what you did not take into account with such broad context is how good the studies are, what you take into account. So was this a study with a large sample size, or was this a study which is methodological sound or not sound? And this is where meta-analysis or systematic review come here into play. Because for the first methods here, it's really, really subjective. I mean, it's completely different when I type something in Google and look for some papers, and Ruben does the same. Depending on what we searched before, Google might give us completely other papers or other results, or at least another order of the results we are going to get then here from Google. Yes, these methods are this is why these methods are not reproducible. And also we might face a publication bias problem, which means that we can only rely on results which are somehow published and not some results which were gone into a file drawer because it was the last part of your dissertation and you could not publish it, or you did not want to publish it. Yes, I mean, we could not take these into account. This is also why they don't give us a broad and correct picture of the real evidence, what is the real evidence on a certain research question out there. Yes, we are also going to deal with certain heterogeneous findings, heterogeneous statistics in these word counting issues, how to put them all into focus, how to compare an odds ratio with an OLS or something. But luckily, there are methods which work better, which are evidence-based methods. So, and we today going to focus on evidence-based maps, which is a method to generate a research landscape, which provides a complete overview on what is out there on a certain research question on a topic. And then when we want to go more into detail and not only want to map what is out there, but also want to go into detail what is substantially found in some papers, we are going to talk about systematic reviews as well as meta-analysis. Says, why should we generally bother? Why should it be systematic? So systematic reviews are essential because they are systematic by design and comprehensive. First, they follow strict methods and a protocol to each step is clear, transparent, and replicable. This means others can verify or reproduce the findings of these steps. Second, they are comprehensive, which means they include all relevant studies on a research question, giving a complete, unbiased answer. So systematic reviews help us to get a reliable and thorough understanding of what the evidence says. So taking everything which is out there into account and boil it down to one statement in the end. So what emphasizes rigorous methods and protocols is the systematic synthesis life cycle, which is like a cooking recipe. The synthesis, so this walks you through all the important steps of a synthesis project. It starts here in the upper right corner with formulating a problem, and here you think first about the research question itself. So what is my research question? And then from this research question, you think about, okay, what makes studies eligible for my research? So what characteristics needs a study to have to be eligible or ineligible for my meta-analysis or my systematic review? And then you write really a list. These are the inclusion criteria, these are the exclusion criteria. Next is sources and databases. So you are really, really transparent in which sources and databases you want to search. And then you list all these databases. So for instance, Web of Science or EBSCO, and which these are crawlers, and then really which search databases to which search databases they are connected. And then in the second step, which is searching the literature, you are again here really systematic. You do a pre-screening. So you judge which studies are eligible, which studies are not eligible, and then from the studies which are eligible, you develop a coding scheme. So which is really a big table where you code everything from a study, like the real result, but also the authors, the study settings. So every logical indicator why two results from two different studies could differ is then here in your coding scheme. And the third thing here is then a coding manual. Just also for others, it's transparent, right? That you know, okay, you can think of a coding manual like a code book from a normal data set in social sciences. So, which really means, okay, coding scheme, whatever, study type equals 1 means experiment, equals 2 means observational studies, and so on and so forth. And then the second step is then the effect size metrics. If you do a meta-analysis here, really it's about, okay, is this paper reporting correlations? Is this paper reporting odds ratios? And also how to transform these different statistical measures into each other. And then last about coding reliability, because if two coders code this same study, you might end up with different opinions and also with different variables. And when you finalize then the step of coding literature, we are then here statistically describing and combining study outcomes. And here again, you describing your mean effect size. So you're doing the really meta-analysis part. But then you also try to explain it. So why is there so much heterogeneity in the studies? And then you do a moderator analysis and try to control for this heterogeneity in the studies. Later on, you do, as in any other statistical analysis in any other paper, also data diagnostics. And then you're, of course, reporting this complete process quite or hopefully as transparent as possible. Yes. So here it was. Okay. Perfect. So let's talk about terminology. We already touched on this a bit. So let's first start with evidence gap maps with the meta-analysis. So they have some commonalities together. They are all systematic, transparent, and evaluative. And an evaluative approach. So where they differ from the other methods I introduced before is because they are so transparent and they follow this process I showed before. And they all take effect size or empirical findings into account. So they could be mean values, mean differences, odds ratios, but also any other statistical or even non-statistical effect size or empirical finding measure. Regarding then the terminology, you might already have seen it from the slides before. So the evidence gap map is a systematic identification and presentation of all empirical findings on a defined question. So it's more a map, and it's something what describes something. It's a description methods, while a systematic review or a review paper is a qualitative thing. So it's a qualitative review which describes the research landscape. So author 1 found that incentives work, author 2 finds that incentives does not or did not work, and they saying something about incentives of €3 work best, the other saying incentives of €10 work best, or something like this. So we describe this complete picture qualitatively, but what you add to this qualitative part, that you can say, okay, we found 100 papers, and 10 were experiments, the others were no experimental designs, some were conducted in Germany, some were conducted in the US, and so on and so forth. Some were conducted on specific target populations. So this is where it comes more into methods. So maybe survey methods or also computational social science methods when you think of, okay, somewhere studies were conducted with data from Twitter, somewhere from other platforms like metadata or so. Yes, and then the meta-analysis, which is then here the largest part. Here you add to this qualitative view onto this descriptive view of the studies and of the descriptive statistics of your study sample. You add then here also some evidence-based accumulation of findings. So then you really have all these, take these studies into account. So these study found an odds ratio of something, the other study found a correlation of something. You transform all these measures into one measure, calculate their variance, and weight these studies by how valuable or how good the sample was. For instance, when we talk about survey data, the higher the sample size was, the better, the more weight is getting one effect size, and then you do a big accumulation of all the effect sizes. In the end, you derive at one certain value, which then can be explored by, is it important whether the study is conducted in Europe or in the US? You can then perform some moderation analysis depending on what could moderate this mean effect here. So when we boil it down to here one slide, so an evidence gap map is showing evidence and gaps. A systematic review is summarizing evidence qualitatively, and a meta-analysis is the statistical accumulation of the evidence. However, this is how we use this terminology is in social science, but for instance, in other disciplines as economics, they call everything, or basically everything, a systematic review and make the point of quantitative or qualitative systematic review. So they don't call it a meta-analysis in general. Yes, I like also this graph a lot, which is from Booth and Grant. And here you see all these steps I introduced you before. So all the systematic steps on the y-axis and the x-axis gave us some ideas for methods, from narrative review to meta-analysis. And always when you have a plus here, this means this study includes this step and this methods. And you see here with meta-analysis a lot of pluses. So because it's also includes a quantitative synthesis of methods, which is here. Yes, so much on this. I mean, it's quite clear that you nearer you get, or the closer you get to the right, the more quality and the more external validity does the method has. You debate. Yes. Then there are no questions here. Oh. How to choose a synthesizing method? So when to choose a systematic review, why to choose an evidence gap map or a meta-analysis. There are a couple of questions you can ask yourself. For instance, how specific is my research question? The more specific it is, the better it is suited for a meta-analysis. How many primary studies are approximately available, and how many are comparable? So the more studies are available, and the more are really targeting on the same issue, the better. Just for meta-analysis, how homogeneous are the methodological approaches in the primary studies? If they are homogeneous, or if they really do the same or compare the same issues in the primary studies, the more they are suited for meta-analysis. When they are really, really heterogeneous, so one study, so all do something with, for instance, survey incentives, but one study does X and the other study does Y, they might be more suited on for a systematic review, for instance, here. On how much time do I have to spend? So in general, a meta-analysis, also a systematic review, take a lot of time. Maybe an evidence gap map, if you are run out of time, is then a better approach. But as said before, I'm going to show you in a couple of seconds 3 case studies what we did with these 3 methods. Yes, and do I get help from colleagues or even student assistants? I mean, with all 3 methods, help from student assistants is really, really helpful because there are some burdensome tasks in general, and also these coding tasks. It's you should always have a second coder and need some help here in general from colleagues then, of course. Okay. When should you consider not using a systematic review or a meta-analysis? So if the effectiveness of an intervention is already established, so traffic lights prevents accidents, so this is already established, a meta-analysis or a systematic review costs a lot of resources. So this is then why you should say, okay, no, I don't want to spend these resources, of course. If there are already 1 or more good systematic reviews in the same area, or colleagues are working on some reviews, and then the next point is if the review question is too vague or too broad. So if it's too vague or too broad, it will be hard to make sense out of a systematic review and a meta-analysis. And when you sometimes might read a systematic review or meta-analysis, which you think, okay, which is not really on the point and not like you don't perceive it as well written or good. This is often the case when it's too vague or too broad. So when the research question is not specific, so that you cannot come up with a final statement in the end. Or if the question is too limited in scope or narrowly focused, that it might be not useful for researchers, of course, if you have insufficient resources to support a reliable systematic review here as well. Here's one study before text mining methods came into play, to be honest, from Allen and Olkin in the year 1999, so it's quite old, but how many hours it takes. So you see the mean hours of more than 1,000 hours on average to create a systematic review or a meta-analysis here at this point, and you see it from this part here. So the problem statement, the searching, the screening, the coding takes almost half of the time, so 600 hours. So lots of time here. And then when it comes to the statistical analysis, I mean, it's always the case, also with survey data or any other data, the time you spend in conceptualization, data preparation, and even with text data, it's even harder, a lot of data preparation. And then when you come to the statistical part, it's quite easy. And also the writing part, I mean, it's all the same. But here, the first part is really, really time consuming when you think of evidence-based methods. But as said before, I'm now going to introduce you in a couple of minutes to new and nice methods, which makes it more convenient to do this, or to choose one of these methods. Are there some questions or so far? Okay, then let's directly come to our case study. So we're going to start with evidence gap maps here. So the aim of the evidence gap map is to identify the identification of evidence and also the research gaps. You can think of an evidence gap map on a quite a big picture you create, and then you see all different X variables and Y variables concerning one research field in one big map. And then it tells you, okay, there are papers which already investigated the effect on X on Y, on X on Z, on X on W. And then there might be also some gaps, what was not researched so far. An evidence gap map or a systematic review or even a meta-analysis are always methods we recommend to the PhD students when they start their PhDs, because it's a perfect idea or a perfect way to get a good overview on the field you want to study. So the good starting point on your PhD. And the perfect idea here would then be you create a systematic review or an evidence gap map, and then you identify some research gaps. So this then here then come your second and your first paper into play. Then you can say, okay, yes, here in my second paper, I'm going to jump in this research gap and analyze the effect on X on Y or something. And then in my third paper, I'm going to jump in the other research gap. And also the positive thing is that evidence gap maps, systematic reviews, and also meta-analysis are cited quite often. So you can cite yourself and saying, okay, this meta-analysis found that there's a research gap, and I'm going to jump into this research gap now with my second paper. Yes. Or you can then also, for instance, get for your own research projects quite a lot of citations, because others are also searching for evidence gap maps or for meta-analysis when they conduct research in this area, because it's quite handy for them to get your meta-analysis, which already does the job, summarizes everything in a quite nice way, and then they can jump in and can say, okay, this is what the latest research status was here in the year 2025 or something, and then they're going to start from this point. This is also why they are cited quite often. Yes, but back here to evidence gap maps. When is an evidence gap map applicable? So when there are new research fields to start with, for instance, now in survey methods, we are heading a bit into the field of data donations, for instance, and then there are some surveys which allow data donations, other surveys which won't allow data donations. And if you want to make a good general statement about the field, so what is already there on data donations, for instance, in survey methods, then you could create an evidence gap map which shows which studies are out there and what they investigated so far. You want to you have quite broad research questions as my idea before, from what is out there with data donation studies. So which survey programs do allow data donations, and how was the acceptance rates by the respondents, for instance. Yes, and also, yes, and then there's some lack of an overview, of course, as well. And I mean, there's a nice evidence gap map also for the field of cyber methods. It's on SNS recruitment, which is social network recruitment. So where persons try to use social network sites to recruit respondents into their surveys. And I think Zindel is her name. She did an evidence gap map on in this field. So this was a perfect time to do it, because thus the field emerged, because more and more people starting the recruitment of survey respondents via social media, and then she jumped here in. Yes. And then what is the procedure with evidence gap map here as well? You define first your problems, or for instance, the social network site, recruitment for a survey problem. Then you define after the problem, you define then your research strategy. So in what X and Y variables are you generally interested? You're doing a proper search for the studies. You're doing the data collections, and then you map all these papers in such an evidence gap map. What I'm going to show you before, what I'm going to show you in the next few slides. So you're going to map them then according to the dependent and independent variables. Could be 2D, 3D. There are even quite nice online tools where you could have then an interactive evidence gap map online. One of these are here from CIA, Campbell evidence, and what I recently found and liked very much is this evidence mapper tool, and some colleagues also using this at GESIS. Yes. Okay. There are no questions here in the chat. Gonna take you to the goals of the evidence gap map and systematic review. So we wrote here in a paper on assessing data quality in the age of digital social research. It was a systematic review, but also an evidence gap map. And This is here my first case study, and also I'm going to show you on the next couple of slides how we made it interactive. So how we made the results interactive of this systematic review or evidence gap map here. So we had here for this paper general 4 goals. We wanted to provide researchers with a decision tree to identify the most suitable data quality framework from a specific use case. So you can think of, you're a social scientist and you're interested in digital behavior data, for instance, and you're more interested in how sound is your measurement and how sound is the representation of your sample you take into account. And then we're going to show you a paper or decision tree which really guides you. Okay, these are the data quality frameworks which are out there, and we would recommend you to look into these and these system. This data quality framework to make use of your data and calculate some data quality indicators here. Yes, the second reason or the second goal of this evidence gap map was to evaluate which social science data types and quality dimensions are already considered in these frameworks. So this depicts general this gap map or this gap view. So we really wanted to make the point. So what data quality frameworks are out there, and now in the year 2024, when we see also lots of new data types in the social sciences, what data quality frameworks are out there, for instance, for sensor data, for text data, for image data, for video data. Are there some out there or not? This takes this gap view into account. And the third goal, which was addressed with this gap map, is that we wanted to consider different types of data to identify the gaps, as said before, which are not yet covered for existing quality frameworks that sound to be considered in future research. So we wanted to make a point, what is out there, what is not out there, and wanted to provide the researcher with help how to find the perfect framework. And the last goal was then targeted on the systematic review part, which is we offer a detailed literature review on data quality. This is then here more the part where the systematic review come into play, where we qualitatively describe all the frameworks we found. And here, this is one of these interactive tools, which is then the decision tree here. It will be also online very soon. And here's, this was the graph represented in the paper. And then here on the interactive tool, you can then really say, okay, you are interested in sensor data, or you're working with sensor data, you're interested in a correctness perspective. So really, how correct is my data? And then you can click here and you find the specific framework or the specific paper, which helps you get going your project and help you to improve the data quality here as well. Yes, and the second part, what we programmed from this was this evidence gap map here. And here again, we mapped all the different data types we identified in these frameworks against the error types. So against from the TSE framework and other frameworks, we identified some error types. So where are data quality problems in general, right? And then we found the dimensional representation, measurement, and also modeling errors. And then we saw, okay, which of these frameworks addressed different error types and different frameworks. And then you can have it interactively and click on the bubbles. You can see in the server world, there are a lot of frameworks and a lot of ideas on data quality already out there, while for other data types, for instance, social media data, there are not so many frameworks and so out there. So yes, and here, for instance, this tool here was created in EpiMapper, which is a really nice tool to to create interactive evidence gap maps. Yes, this was it so far to evidence gap maps. I'm gonna stop.
Can I ask? So you programmed these tools, and now researchers who do evidence gap maps or systematic reviews would be able to use your tools for to put their papers into these tools, and then third parties could say, okay, I look at this review and now I can click through the different types to see where there are still gaps.
So actually, so two questions. So there are these general tools, right? For instance, this EpiMapper tool, but it's not a tool what we developed. It's developed from the Campbell collaboration, so it's not developed by us. But what we did was to conducted this review and then try to make the best out of the information that others could learn, which data quality framework they could target. But the tools itself, they're completely, I think EpiMapper is completely free, available. Also, this other tool I recommended before for evidence gap maps from the 3IA guys from India. This is also completely free. Yeah, so there are tools out there what you can use, but we made here use of it and made the point of data quality that they can find a proper data quality framework. Thank you for this question. Okay. Then second part, which is now systematic review, and I also have a broad analyzed case studies, what a systematic review is here with me. So what is the aim of a systematic review? To identify so the identification and descriptive or qualitative presentation and evaluation of the evidence. So here you want to identify the evidence first in this systematic approach, and then you want to qualitatively describe this evidence. When should you conduct it? There is two heterogeneous evidence to conduct a meta-analysis, for instance, or the research questions the primary researchers picked are too heterogeneous. You could not make sense out of them because they are too broadly defined. For instance, they broadly define some measurement constructs too broadly. One took this variable or this measurements construct into account. The other paper took a completely different measurement or question battery into account, which are not comparable at all. And so you might then end up with a qualitative systematic review in the end. Here again, you have the problem statement as the first step. Then you are doing the literature search, then do all the data collection, which papers should come into your systematic review. And then you're doing here the descriptive or qualitative evaluation and presentation. This is what I mentioned before. You can create nice graphs, which is where is this research come from? So for instance, some research is from proper papers which are published, some are conference proceedings, or you could make the point of some evidence which was conducted in the US versus in Europe versus in Africa, and then from this you could make sense why the results differ, for instance. Yes, and there's also some further literature out there, and if we now go through a case study, it's a case study from Caroline Roberts on satisficing in surveys. If you're not familiar with the concept of satisficing in surveys, so satisficing is a broader construct in general, and you can have different measures of measuring this satisficing construct. So for instance, you see here a question battery, and one part of satisficing according to the response burden theory, which means that respondents want to shorten the questionnaire and don't want to spend too much burden on this questionnaire. They, for instance, only pick here the extreme values, or only do midpoint responding or something. So there are different measures you can think of such a question battery. which measure the broader construct of satisfying. This is also why it was a perfect value or perfect case for a systematic review. If you were, for instance, only interested in the mean number of extreme responses in a survey, this could more be than a meta-analysis, because the construct you measure is really close, right? It's really, you're only interested in extreme responses, but you're not interested in midpoint responses or on other parts of a survey or of other satisfying strategies in a questionnaire. And then when you only would only be interested in extreme responses, a meta-analysis would suit. But here, as Caroline Roberts was interested in a lot of measures which are clustered under the umbrella of satisfying, she wrote a systematic review. And then she made one part on extreme responding, she made one part on midpoint responding, she made one part also on time measures and online questionnaires and so on and so forth. And what she then presented were here, for instance, all the papers, what she included in this study, and also here the search strategy. So she searched somewhere in June in one of the journals, which is Public Opinion Quarterly, and these are the search terms she used. So she made it really transparent. And then she defined some inclusion criteria, what I came up with before. So she only included methodological focused papers, only English language papers. She put in these papers or made her search strategy really transparent. So all the search terms she used, for instance, and then she came up with different findings. So first she described the results of this paper qualitatively. So what is missing in the satisfying literature out there? What is the point of midterm responding? What is the point of extreme responding, for instance? But she also created some graphs, which is here. In the first graph, the papers which targeted on satisfying across the years, or here how satisfying was measured. For instance, response order effects, she found a couple of studies. Non-differentiation issues, she found a couple of studies. Interview pace, she found a couple of studies. So how this measure was generally set up. And what was interesting here, for instance, you were only interested in interview pace, to include these 18 studies into then a meta-analysis, because they all measure exactly the same idea, or they had all the same idea and all measured the same effect size, it would be possible to do a meta-analysis of these 18 studies here, for instance, in this line. But it would not be possible to push everything in one meta-analysis and try to homogeneous to make these different measures or different data quality measures homogeneous then. Yes. I think this was it for systematic reviews. Are there some open questions or issues here? No. Good. Then let's come to the last part, to the quantitative part, to a meta-analysis. So here, so we have here the aim, which is only reserved for meta-analysis, which is a quantitative systematic presentation of empirical evidence on a common question. So it's statistically summarizes the distribution of findings and describes and clearly describe and clarify the heterogeneity of the distribution of the findings. This means that you include lots of studies in a meta-analysis which have different backgrounds, as said before, for instance, some countries they were conducted in, and then you can create a variable which tells you, okay, 1 means Europe, 2 means Northern America or something, 4 means Africa, and then you can control for these. So you have then your mean effect, and then you can control, okay, is the mean value significantly different if the study was conducted in Africa versus in Europe or something? Yes, and then when can you conduct, sorry, there's a typo, but when can you conduct a meta-analysis? So if there are sufficient studies, some meta-analysis guys saying, okay, sufficient studies, you need 2 studies to conduct a meta-analysis, which is literally yes, but actually, of course, not. So as more studies as you can implement in a meta-analysis, the better it is. And I usually recommend in the courses that at least 10, 12, 13 studies should be there, which measure exactly the same to make sense of this and to include in your meta-analysis here. And here again, you have the procedure, you have the problem statement, you do the systematic search, you do the data collection in a systematic way, and then you have the statistical synthesis and analysis part and the representation of results. So so to be honest, so just the first part of my dissertation, so my first paper was also a meta-analysis where I learned this from, and so in the end I'm really happy that I did it, because of many reasons, but also because of the reasons as a meta-analysis is always really, really valuable. And it was cited quite a couple of times, and it was published in a quite good journal. Then, yes, this is also why I would recommend going into these methods and start maybe with a meta-analysis or systematic review here. So we have here, the problem is the response rate for web service lower, the same or higher than for other survey modes, and why is that the case? And here we compared in all experimental studies which were out there, where respondents were randomly assigned to either a survey mode, which was web mode, or another survey mode, which could be telephone mode, face-to-face mode, or mail mode. Yes, and then we had here the second and third we had here the inclusion and exclusion criteria in our search procedure here, which were then that we only wanted to include studies which were used randomized control trials, also where they really assigned randomly these guys to one of these methods here. And we also had the inclusion criteria. What was it again? That I think, yes, we only wanted to include English published studies because we could not use other languages, for instance, but we did not make a geographical focus, so we wanted to include everything which is out there, also unpublished literature. So dissertations or conference findings or something. Yes, and then in the end, we ended here up with 115 effect sizes here, nested in 97 studies. So this means in the end we had 114 comparisons between web and other survey modes. These were nested in 97 studies. So some publications also present like 2 different surveys or 2 different trials where they conducted this experiment. This is why we have had then here the difference between studies and then also manuscripts, and they were then in the end published in 75 manuscripts. And then in the very end, we had this nice graph which tells us, okay, beginning from the year, I think it was a cumulative graph, so it tells us what happens over time. So, and you see here the little pointer, which is the mean difference between web and other survey modes, and it basically stayed the same for a lot of years. So then in the year, what was it, 2019 or something, web surveys received 12% lower response rates than their comparison modes. And then we wanted to make the point and ask, why is this the case? And we tested for some survey methodological aspects or moderators which could explain this effect. So is it important whether the respondents were how they were sampled, when they came from an existing list, or when they came from a panel, or when they were completely newly recruited. And what we can see here, when they were completely newly recruited, for instance, the gap between web mode and the other survey mode is even higher. So there are all, in general, 16% lower response rates from web survey respondents, which were newly recruited here, for instance. Yes, and also we tested for some countries, but I think, these effects were, yes, they were all significant. So it's also dependent on in which country the study was conducted. So what was so different, whether the study was conducted in the US, there the response rate was a bit lower. So the gap was a bit lower than compared to the UK or the Netherlands. Yes. And so much on this. Are there some questions on this? On meta-analysis or even on the general case study topic? Need to check the time a bit. Okay, then let's come to the cool part. Some new cool tools improving your life. So for instance, of course, ChatGPT is really good in writing search strings for these big crawlers. So a search string which you can then directly implement into EBSCO or Web of Science should have different attributes. And for instance, ChatGPT is perfectly aware of this. I asked it to provide me a search string, and then also I asked it to give me some synonyms for certain terms, and then it worked quite well. So in the first trials with ChatGPT. So yes, I did some experiments here, but yes, in general, as I said before, it worked quite well. And then it gave me a nice search string, which said it understood that web survey is the same as internet survey or online survey or e-survey or web-based survey or so on and so forth. And then says, and take the experimental setting into account. So take experimental or experiment into account. And then I'm only interested in survey interviews or in surveys and not in criminal interviews or something. Then it took me survey mode, data collection mode, response rate, blah, 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 into account. And then, yes, this worked in the end quite well. What is also quite nice is the R tool, Let's Search R. Yes, I mean, how it works, Let's Search R, it's an R package. It is used to repeat automatic keyword extraction algorithm. So it works the following. You do a manual search of some papers which are relevant to your research, or to your meta-analysis or systematic review or whatever. And then you feed in the keywords, the abstracts, and the titles of these papers into R. And it does automatically check all these different abstracts, all these different titles. And then from these titles and abstract and information, it creates your nice search string, right? That is quite automatically. So based on these findings I already had, these are some synonyms they might also use for the same constructs, and then it helps you and creates a nice search string here. Yes, there's also a nice tutorial there. Yes, and then it even gives you back so nice word clouds, how words can be disentangled, or so like in a lot of studies where we found electronic health or record or data quality, these are more studies which call it data management or so. So you can play around with these kind of things. It automatically removes you duplicates, and then you might then need to help this program again. So it gives you then some terminology out there, and then you need to group the common terminology yourself. So you need to say, okay, these are different constructs which are different parts where my search term should consist of, and then you collect them yourself or like order them yourself, and then you play the ball then also back to lit search R package, and then it creates you the search term from this, but it's quite easy to learn. Yes, and they also had a new Shiny app. If you don't like R, they have a Shiny app somewhere out there in the internet. Lisa Graves, I think she programmed it. And yes, here again, you give them the studies you identified for your research, and then you played a bit around, and it gives you a perfect search term you can use for literature extraction. Snowballing is easy too. So snowballing means think of some papers you identified, and then all these papers have these really, really long reference lists. And snowballing is quite easy with the citation chaser package, because you upload those papers, so those reference lists, and it automatically checks these reference lists whether there are references which could be valid for your meta-analysis as well, right? So all this manual checking with going through each and every reference of these long reference lists is really easy now with taking the citation chaser package here as well. And I mean, you might meet Research Rabbit. This was a tool I did not know so far, but a student recommended this tool in the last meta-analysis course in Lund. And I already checked it. So it's a literature, it's a system, like a literature organizing system. And you have your library there, and then it even finds you papers which are similar to your library, and then it creates these nice graphs. So these are papers in your library, and then there are other papers which are referenced and cited reference or do reference some other papers, and then it gives you even more papers which are really, really similar to the papers in your library. Yes. The EPI reviewer, I mean, I mentioned the EPI mapper before. This is with the software we created this evidence gap map. But also the EPI mapper is a nice tool to automatically find literature and organize literature for systematic reviews. It's completely, it integrates with research tool, links to OpenAlex and, for instance, to Zotero, and it's from anywhere accessible. And yes, you can just check it out. Yes, and what is the biggest game changer in all these meta-analysis and systematic review issue is AS Review. It's programmed from Utrecht, from some guys from Utrecht. I think they were psychologists or so. And the traditional way you already have understood it from the things I said before is you were there with, this was my first paper with lots of literature, and I needed to screen the literature myself, and it was really burdensome and took long hours to do this meta-analysis. And then you select the record, and then you check the next record manually, and so on and so forth. And then in the end, I had to screen whatever 500, 600 records myself. But now there's a nice tool which is also based on text mining methods in Utrecht, and this is really, really cool, because you do the searches in EBSCO or other search engines, and then you upload all titles, all abstracts, all keywords. So just the file you get from these crawlers, so just the file you get from EBSCO, for instance, you upload to AS Review, or I mean, it's a Python thingy. You upload, you make it ongoing in Python, and then you are rating manually some of the papers as relevant and some as irrelevant. So some of the papers you found, and then based on your ratings, it compares the texts, the abstracts, the titles, the keywords to all other literature you uploaded, and then it gives you the next reliable paper. So from all papers which are out there, it compares the titles and the abstracts, and then it presents you the most likely next reliable paper. And then you can say again, okay, it's valid or it's invalid. And then you can say, okay, valid. And then the algorithm even improves and understands, okay, this paper is also valid and eligible for her research. So and then it checks again all the abstracts and all the titles and presents you again the next valid or eligible paper. And now this perfectly improves the process of a systematic review. And there are also nice explain videos out there. Yes, I mean, I did it in Python, but I already learned that there is also I think a version, an online version where you don't need Python anymore to use it. Yes, it's in Utrecht. I mean, there's, as I said before, some nice videos, and then we'll skip these a bit. This is how it works. So, for instance, here I evaluated some as relevant. These were these with the little hearts, and some when I want to say, okay, these are not relevant, then I said, okay, this paper is not relevant, and then from my primers, the algorithm learns and presents me the very next relevant paper then. And yes, and then I needed to classify them here as irrelevant and relevant. And then in the end, we had 8,200 or 8,300 records identified through our screens for the data quality assessment paper. And then we labeled, so 845 were then labeled, and then we identified 67 records as eligible and 375 as irrelevant since the last relevant. So it works then the following: in the beginning, it presents you the next relevant paper, and then we said yes, relevant, and then some irrelevant, and then you can see then there were a lot of irrelevant paper, and then we stopped somewhere the literature eligibility criteria checking process, where we found, like, where we had, I think we stopped it when we had 800 irrelevant paper since the last relevant one, and then we don't needed to check all the 8,000, but in the end we checked whatever 1,100 or something. So really a game changer, and this is really cool tool. Yes. And what we lately tried was also quite nice. The next step in a systematic review, where you then stopped in the process where, okay, we identified 50 papers as eligible for our study, and we wanted to make use of these papers. Then we tried to use ChatPDF for coding tasks. So you can upload some papers, and then you can ask ChatPDF, of course, so how many, what was the sample size in this study, and what survey modes, for instance, did they use, or something like this. And it worked quite well for some papers. For other papers, it did not. But I mean, you could try it out. But some, so far, I don't understand why it worked in some papers quite good, and others papers not so good. But I mean, it's still, I think it will be will improve the algorithms will even improve in the future. So I think in the quite near or not so near midterm future, we could use ChatPDF to coding tasks here as well. So to sum these new developments a bit up, there's a hackathon thing which is called Metaverse, and they are doing constantly hackathons and meta-analytical methods, and it's always good to check the Metaverse website. And here are some other useful tools to create these nice Prisma diagrams really easily, or check for gray literature. And here's also the link. It is ES, so effectsizehackathon.org, and yes, it's a nice initiative. Yes, and here's even some more. Yes, I mean, there's also Rob risk, create publication quality, risk of bias assessment figures. So whatever you want, there's something out there, or probably something out there in this effect size hackathon. So give it in general a look if you're interested in these topics. Yes. So are there more questions, or are there any questions or ideas? I don't know, 15 minutes left. Okay. Then let's come to the very last part, which is a quick one. Yes, so again, the synthesis life cycle, and then the question how to review an evidence-based methods paper. And if I write a review on one of these papers, I always have the synthesis life cycle in mind. I go through each and every step and ask for what can go wrong, and then I check the paper, like what can go wrong. And this is then how I write a review for a journal or something. And I mean, even when you're not so interested in these methods, to use these methods yourself because they are too time consuming or so, then it might be the case that you in the future might have one of these papers on your desk where there was meta-analysis conducted and you wanted to review it. So what I really can recommend is the American Psychological Association, because they published some criteria, what should be included, like a checklist in the systematic reviews. These are available for free, easy to understand, and ensures the integrity and replicability and provides useful hints. So these are just don't want to go into detail. It says for the abstract, what should be included, for the introduction, what should be included here, for the inclusion exclusion criteria, what are the information which are necessary, which should be reported in the paper, and then you can check with the review you're writing or the paper back what they said on their search strategy, also what could go wrong for the search strategy. For instance, here also the number and qualification of relevant judges, if they had several persons who coded and searched for the literature or only one person, and it just gives you some ideas what can go wrong in systematic reviews. And meta-analysis is also for the statistical methods. Here again, they ask for how heterogeneity in effect sizes was assessed or estimated. So they bring you to the point to think about, are these effect sizes heterogeneous? So are they really measuring the same, or are they conducted in different contexts and measuring different things? Yes, also for the results part or the discussion part. So if you are writing a review, please check these criteria. Then let's come slightly to some last thoughts to an end. So there are some critical or some reviewers when you submit a systematic review or meta-analysis, which might criticize the methods in general. They are sometimes saying a systematic review or meta-analysis is just a form of waste management process. You put lots of waste together and produce even more waste. There you could argue, for instance, it's really systematic. We had reliable inclusion criteria, so eligibility criteria, which then means we only took experimental studies into account and left all these lower quality case studies by side, or other arguments you didn't have, and you argument with the systematic approach and with the eligibility criteria that not included everything, but you only wanted to include the very best to make it homogeneous. Then another criticism is a systematic review compares apples with oranges and cannot result in a reasonable finding. And here again, it's about arguing in the sense of homogeneity of your results. It does not make sense also in the beginning for meta-analysis that you want to explain the complete world, like Caroline Roberts. It would not make sense to explain satisfying this broad concept with one final measure in a meta-analysis, but it made sense that she wrote a systematic review, because also the concept of satisfying has so many facets that she could tackle in the part of a systematic review here then as well. Then another criticism is a systematic review misses all the unpublished studies. Yes, I mean, if you only included published studies, this could be a problem, but there are certain methods, for instance, publication bias analysis with Egger's regression test. And here you can definitely test for whether there's a significant gap of small effects and insignificant effects, because you might anticipate that studies which are not published or only were drawn into the file drawer, they have smaller effect sizes and insignificant effect sizes, and you can test for this, whether there's a gap and you included too less of these types of effect sizes. And then all studies with multivariate outcomes cannot be included in the result. This result is a biased result. I mean, here's the only thing I have to say. Yes, so there are methods to include multivariate outcomes in meta-analysis, which is then with Bayesian statistics, but with the normal methods I referred to here, it's still not possible to include regression results. So the reason behind this is because one paper controls for 10 studies and has a mean value, and the other paper controls only for 5 other variables and has a mean value, and then you could not compare these together because the controls were completely different. This is why meta-analysis usually take bivariate statistics into account and then only control for these moderators, how these different methods here differ. Yes. Review responses are here written down, so the garbage in, garbage out refers to the notion that meta-analysis includes many low-quality studies. This is what I said before. I just wanted to make it visible on these 2 slides here. Again, okay. Then to summarize or to sum everything up, so an evidence gap map is more or less a presentation of the evidence, and if applicable to point on research gaps, you remember the bubble graph I showed before, and then therefore this one column, which was, I think, graphical data, there were no data quality frameworks at all, so no research out there so far in the social science data field. And for the systematic review, it's a qualitative synthesis and a description of the results. You remember the satisficing paper from Caroline Roberts. And then meta-analysis is then a quantitative synthesis and a description of the results in a statistical way. Yes, and if you're planning a certain project and want to check back with the methods or something, we have in GESIS a consulting form, so you can contact me if you like, and I could help you out and give you maybe some ideas how to conduct your systematic review or meta-analysis. Yes, are there more questions? There's one in the chat, I think. Well, Valerie, do you want
to... Is it okay if I just go ahead? Can you hear me?
Yes. We can hear you, yeah.
Okay, perfect. Thanks so much for the very interesting overview, and I have a lot of practical things to take away from this. And my question kind of concerns the first element of the cycle. I've been thinking a lot about how to pre-register more systematic reviews or meta-analysis, and my question is, what is your experience with this, also in terms of review processes? And then secondly, are you aware of tools or hand-on applications on how to do this? Because I've seen examples, but I feel like there's not a lot of standards.
Yes, for pre-registration. So we lately pre-registered 2 of our studies. And usually we really took this life cycle into account and wrote something on each and every step of the life cycle, what we wanted to do and how the study should be set up or something. So I think this life cycle graph is a really good idea how you could guide your pre-registration somehow.
Okay, thank you.
Are there more questions somewhere?
If not, thank you very much for the talk. This was quite a lot of very helpful resources if we're planning some review studies, and I learned a lot. I never knew how to do them, and I was afraid if I would do something like that, it would take a lot of time, and I think that's kind of the case. Yeah, thank you very much again, Jessica. Fantastic presentation. Yeah, this ends our session today, and we just heard from Valerie via the Zoom chat and speaking over the Zoom. And you will actually be our next presenter in the Social Science Data Lab. So our next event will be back on November 20th with an input talk by Valerie Hase from LMU Munich on data donation. So tune in or swing by. Thank you for joining us today and see you next time.